Okay, today we're going to talk about some of our rules for comparing fractions. The first rule that we have is if the fractions have the same numerator, that means they have the same number of pieces. The fraction that has the larger sized pieces will be the larger fraction. So let's talk about this a little bit more. So in our example, I have the fractions 2/5 and 2/3. Both of them have the same numerator or number on top. Now we talk a lot about how the numerator means the number of pieces that we have, and how the denominator means the number of pieces that make a whole. So in this picture, you can see that we have a piece that is cut into thirds to match here, and two of them are colored in to match here. We have another piece that is cut into fifths, like our denominator here. And two of these pieces are colored in just like the numerator here. So as you can see, the numerators of these fractions are the same, which means they both have the same number of pieces. This fraction has 2 pieces, and this fraction has 2 pieces. When both fractions have the same number of pieces, then we have to look at, well, how big are those pieces? So I have to think, are thirds bigger or are fifths bigger? In my picture, I can see very clearly that 2/3 is a lot larger than 2/5. But what about when it's harder to tell with a picture? Usually we have to have a second strategy in mind. So in this situation, I know that if I have 3 friends sharing a brownie, that we're going to get a bigger piece than if I have to share it with 5 people. So since thirds are larger than fifths, because we're splitting it into a smaller number of pieces, then 2/3 would be larger than 2/5. Our next rule for comparing fractions is if fractions have the same denominator, that means the pieces are the same size. The one with more pieces will be the larger fraction. So let's see an example of this one. I have 2 fractions here, 3/8 and 5/8. Remember, the numerator means how many pieces we have in the fraction. So for this one, we have 3 pieces colored in, and this one we have 5 pieces colored in to match. But they both have 8 as the denominator. That means that both of the wholes are cut into 8 pieces, which means the pieces are going to be the same size. So if my pieces are all the same size, and this bar here has 3 pieces, and this bar here has 5 pieces, which one will have more? Well, since they're the same size, the bar with 5 pieces is going to be greater than the bar with 3 pieces. We often talk about in class how this is kind of like sharing M&Ms, because M&Ms are all the same size as well. So if I have 3 M&Ms and you have 5 M&Ms, who has more? You do, because 5 is more than 3 if they're all the same size. Okay, and the last rule I wanted to talk about today is rule number 3. If fractions are missing the same number of pieces to get to a whole, then the one that is missing the smaller sized pieces will be the larger fraction. Now I know this sounds a little bit confusing, so let's see an example. Here I have 2 fractions. I have 4/5 and I have 7/8. In each fraction, if I were to increase by 1 more piece of the same size, so 1 more 1/8 for this one, and 1 more 1/5 for this one, I would have a whole 5/5 or 8/8. They are both missing 1 piece from being a whole, like 1 whole. So if you look down at our picture here, I like to talk about this like juice cups. So if, for example, I have a cup of juice that is 4/5 of the way full and a cup of juice that is 7/8 of the way full, which one is closer to the top? Sometimes we have to look at the size of the piece that we are missing. So if I am missing 1/5, from getting a full cup of juice in this fraction, and I'm missing 1/8 from getting a full cup of juice in this fraction, Which one is missing the smaller piece? Well, we know that since we cut eighths into more pieces than fifths, that eighths are a smaller piece, so it's closer to being a full cup of juice. Fifths is missing a larger piece, so it's farther away from being a full cup of juice. So now I know that 7/8 is a larger fraction than 4/5.